unmarked waterway, and same in outside the marked channel. This is pretty interesting. I just did a chart, and the interesting thing about this chart is the distribution. Outside the marked channel accounts for 48% of the groundings, so it counts for most, but it only has 5% serious marine incidents. So if you go to the next one over, unmarked waterway, it accounts for about 10% of groundings, but it almost has double the rate of serious marine incidents as compared to outside the marked channel. And as you see, if you look over to the left, the marked channel is the smallest. So it seems to be an initial indication that the severity of accidents varies by location, i.e., what it looks like is where we're not placing our attention, or we have placed attention there, we made an informed decision, is where the most serious accidents are occurring at a higher rate. So I did my analysis, and from this analysis, using the biostatistics techniques, you can find out the rate of serious marine groundings. There's 5 serious marine groundings per 100 groundings occurring outside the marked channel. There are 3 serious marine groundings per 100 groundings occurring in the marked channel. So already you know there's a difference of 2%. So 2 per 100 serious marine groundings are a result of, that's the additional risk of running aground outside the marked channel. And groundings outside the marked channel are 59% more likely to be a serious marine incident compared to groundings in the marked channel. So that says, hey, Mariner, if you stay within the channel, the marked channel, more likely than not, you're not going to have a serious marine incident. It's showing that ATON has an effect. Now, if we compare this to unmarked waterways, if you can see, it's almost 11 serious marine groundings per 100 groundings as compared to approximately 3 in marked channels. It's 278% more likely to be a serious marine incident in an unmarked channel relative to the marked channel. So running aground in the unmarked waterway increases the baseline risk of a serious marine incident by approximately 8%. The other interesting thing with this biostatistical technique, it tells you how many people you need to treat or how many groundings you need to prevent one serious marine incident. So if we prevent 58 groundings that are outside the marked channel, we will stop 1 serious marine incident, compared to 12 for groundings in unmarked waterways. Now this, on the face of it, would say, hey, where am I going to put my money to get the biggest bang for the mark? Biggest bang for our money is to put it in the unmarked waterway. Well, that's not, you can't necessarily do that with this. You need to do additional research because there's a reason why that waterway was unmarked in the first place. You actually have to go and look at the variation of all the different reasons why it was a serious marine incident and make a decision, a policy decision. So our overarching challenges as marine administrations is we're going to always have to demonstrate safety benefits, contain costs, and improve navigation safety. IALA can help this by addressing performance measurement challenges. So we already have an aid availability standard. There is an IMO standard on how to categorize accidents. We just have to tie that back into the larger marine safety system. Because ultimately, if we can't tie ATON or navigation safety back to the larger marine safety system, we're always going to have this problem of demonstrating our benefit. So aid availability and the number of accidents are necessary but not sufficient to measure navigation safety performance. If we expand the suite of performance metrics, we'll be able to provide our decision makers with more information about where to allocate resources within the program and to what type of programs, which would be a tremendous benefit. And the other challenge we have is that compared to the total volume of traffic, groundings are really rare events. They're high consequent events, but they're rare. By standardizing performance measures and working together, we can have approaches that will address this rare data issue, and I believe we're close. It's like low-hanging fruit, in that taking this biostatistical approach is a first step to do any longer, more advanced research agenda. And I think by seizing this opportunity, IALA can improve navigation safety by helping nations demonstrate safety benefits, contain costs, and improve navigation efficiency. I covered a lot of ground. I know it was quick. I reduced my slides. There's a lot of theory. So if you got any questions or comments, I'd be more than happy to talk about this.
Thank you, Mark, and all the people for the long presentations. We have now actually a few minutes for questions. Anyone? Oh, a lot of. Okay, Peter.
Mahesh, it was very interesting to see how a method has actually been used and see all these measures. But to what extent have you, to this until now, measured the effect of these measures and have they been validated? The reason why I'm asking this is because I find it extremely important that you have been using this tool and it has resulted in very concrete measures. It would be really strong and a success story if we could have the effect and have it validated. Thank you.
Thank you for that very good question, Peter. As I said, we conducted these workshops in the middle of last year. We have now approval from the government to go ahead to develop this maritime management plan. So we're really at stage one, and perhaps in the next 12 months we can report in some other forum on the effectiveness. But specific risk factors like the Universal Shipwetting Program, we've already started pushing that through a forum called Ports Australia, encouraging harbour masters and port operators to put these measures in place. And we're pleased to say that they have taken these recommendations on board. So the short answer is we'll come back to you with more information soon. Thank you.
Okay, next one. Keith.
My question is for any other people involved in risk management. All the model are focused in an approach in 2D, only in the plane. So, but the collision, the grounding is related to the deep, to the 3D. And you evaluate or have any intention to extend the model to a 3D models, including the deep, and how is the effect of the charging? Because I think all the IALA members are working very hard in spending money in marking